Here in number 5, notice it says which graph represents f of x is equal to 3 times 2 over 3 to the power of x. Now, what I hope you realize is this is just an exponential function, and when you get an exponential function like this and they're giving you pictures, I believe the best thing to do is just graph it. But before we even graph it, let's see if there's something we can cancel out. So let's go back and write our exponential function. It's f of x is equal to a times b to the power of x. That is our equation for exponential functions. And what you got to remember is that a is always going to be the y-intercept. And I want you to remember that b is going to represent your growth or decay factor. In other words, it's either going to be 1 plus. In case of growth, you have 1 plus r. And in case of decay, you have 1 minus r. Now, I'm going to use this idea of that a is the y-intercept to go ahead and try to eliminate some of these possibilities. Now, I do want you to notice that my a value in this equation is actually going to be 3. So I'm going to go ahead and box that. So I should have a y-intercept of 3, because if I wrote the equation that it gave me, it said f of x is equal to 3, which is my a value, times 2 over 3, which is my b value, to the power of x. So a is going to be 3. So anything that doesn't have a y-intercept of 3, I can just cancel it out. It's not an option. So let's look at the first one. And when we talk about a y-intercept, I want you to remember that the y-axis is this one that runs up and down. The one that runs left to right, that is my x-axis. So when they say y-intercept, what they mean is that it's going to cross at positive 3. So if I count up 3 times from origin, that's going to be my y-intercept right there. So I need to be crossing the y-axis at 3. So number A, notice it crosses at 1. So it can't be A. Cross that out. B, notice it crosses at 1. Right there, crosses at 1. So I'm going to mark that out. Okay, so C crosses at 3 and D crosses at 3. So now we actually have 2 answer choices, right? These crossed at 1, so they were both wrong on top. This crosses at 3, this crosses at 3. So I don't know which one of these is correct. So in order to figure out which one's correct, I'm going to need to graph both of them and see which one looks correct as far as the picture goes. So notice this one, it goes down, right? It curves down, so it decreases as x increases, y decreases. And this one, y increases as x increases, and it goes up. So I'm just going to see if my picture goes down or if it slopes up. So let me go ahead and get my calculator real quick. I'm going to go to graphing. So I'm already in graph, so what I'm going to do is just go ahead and hit home to get out of there. And then I'm going to go ahead and hit enter on this graph button right here again. And let's type in what we had. So if I go back and I look at what we had originally, it says f of x is equal to 3 times, hit control divide to get my fraction bar, 2 over 3, close parenthesis, to the power of x. And then hit enter, and let's see what we got. And notice that my graph, right, it curves down. So as x increases, y decreases. And so if I go back to my answer choices over here, that would be answer C. So I'm going to click on C, and that is the correct answer. So now pause this video, and just remember that you do have to write a reflection. So either explain to me how you got it right, if you got it right, or if you got it wrong, explain to me how you saw me get it right. What did that process look like? Keep it short and simple though. And then move on to number 6 and see if you can get it right before watching the video any further. Here on number 6, notice it says for quadratic function f, the solutions to the equation f of x is equal to 0 are x is equal to 7 over 5 and x is equal to negative 2 over 3. Which function could represent f? So notice that they are giving us two solutions here, right? They said that the solutions to the equation of f of x is equal to 0 are 7 over 5 and negative 2 over 3. So I want to know which one of these has those solutions. Now, I want you to remember, we're going to make a note right here, that when we talk about solutions, specifically when we're dealing with a quadratic, and remember these are all quadratic because the first term is squared, right? Has that power of 2. So I'm going to write of quadratics. I want you to remember that they are also called roots. We also call them x-intercepts. And we also call them zeros. So that's all it's asking for. It's just asking for the solution, which is the same thing as the roots. The x-intercept are the 0. So what we're really trying to do is we're trying to look at an image, right? So if I were to draw a graph, we have an image here, and if I were to draw it, and I'm just gonna draw a basic parabola just to give you some examples. Let's say it looked like that. We know that it crosses in two places, one on the negative axis and one on the positive. And according to this story up here, right, it says x is equal to 7 over 5. So the positive one where it crosses is 7 over 5. And the second one where it crosses, the negative side, is negative 2 over 3. Now what I'm going to do, before I even try to solve one of these right here, I'm actually going to go ahead and just convert these to a decimal. Because a lot of times if we type it into the graph and find it, it's going to have these answer choices as a decimal. And if you don't convert it, you might not be sure what's the right answer, even if you get the right graph. So I'm actually going to come over here to my calculator. Let's do some conversions real quick. I'm going to go home. I'm going to go up to calculate, and I want to convert this. So I have 7 over 5. So control divide, 7 over 5. Put a decimal after it, and then hit enter. And notice that changed it to 1.4. So for this one, I'm going to say, okay, this one was 1.4. That's my 0. On the next one, we had negative 2 over 3. So I'm going to put that in my calculator. Negative, control divide for my fraction bar, 2 over 3. I'm going to darken this up just a little bit. And then I'm going to put a decimal after it, and I'm going to hit enter. And notice it gave me negative 0.6 repeating. So I'm going to go ahead and write that down. So this one is going to be negative 0.6 repeating. So now I know what my two zeros are in decimal form. So let's go ahead and graph this. Now, the good thing about graphing it, right, is they gave us the function. They said that there's these 4 different functions here, and that one of them represents this situation. So what I'm going to go ahead and do is I'm going to graph each one of these and see which one has a 0 of 1.4 and negative 0.6. So let's try the first one. So to graph it, I'm going to go home. I'm going to go down to my favorite graphing function down here at the bottom. I'm going to hit enter. And let's put this first one in. So we have 14x squared. So 14x squared. And then after I got that, I'm going to go ahead and put plus 11x. So plus 11x. And then we have minus 15. Minus 15. I'm going to hit enter. So there's my picture. Notice, right? I can see it right here. So what I want to do is I want to find my zeros, right? Or my roots, and see, are these the two places where it crosses? Because it does have one on the negative side and one on the positive side. So that might be correct. I'm not sure. But we got to look it up and confirm. So I'm going to hit menu. I'm going to go down to analyze graph. Click to the right. And notice it has all these different options. So notice that in the calculator, the word that we use is 0. So it doesn't say solution, it says 0. But remember, solutions, roots, the x-intercept, and the 0 are all the same thing. So I'm going to hit enter on that. Now I do have to move this cursor over here to the left of the line and hit OK. And then drag it to the right and hit OK again. And notice that one gave me negative 1.5. So I can already tell you, looking at that, right, that's not the same thing as 1.4. So this is going to be wrong. But if you wanted to, we could check the second one. Let's just check it and see what it says. So I'm going to go to Analyze Graph, click to the right, and I'm going to go to 0 once again. And to do a second 0, I got to move it to the left of the line I want to check. Click it, and then move it to the right, and click it again. Alright, so I'm gonna move this first one so I can see better. And this one looks like it gave me 0.714. And that's not the same thing as we had here. Here we had 1.4. So the first answer is incorrect. So I'm going to do a strike through real quick. So it's always good to strike through the answers that are not correct. And now let's try this second. We're going to try B. So for B we have 15x squared. So I'm going to go back out and back in. And I'm going to type in 15x squared. And then it says minus 11x, so minus 11x. And then minus 14. Going to hit enter. Alright, and once again, right, we have it crossed in 2 different places. So let's check the 0. So I'm going to do menu, go down to Analyze Graph. I made this a little too dark. Let me adjust this real quick. There it goes. Okay, notice it does say 0, so I'm going to hit enter. I'm going to drag this over to the left, click on it, drag it to the right, click on it, and once again I think this is already wrong. This does not match the 0 that we had. I'm going to move it up here so you can see it better. Oh, I thought it looked like a 5. I thought it didn't. You know what? It actually matches. Look at that. We have negative 0.667, and this is 0.6 repeating. So you know what? This one's good. Now, if the right one is 1.4, then we got the right answer. So hit menu, go down to Analyze, and then 0, and hit enter. I'm going to move my bar right to the left of the line I want to check. Hit OK. Drag it past, hit OK. And notice, look at this, it gives me 1.4. That's exactly what we were looking for. We were looking for zeros that were negative 0.6 repeating and positive 1.4. So B is the correct answer. So I'm going to go over here. I'm going to go ahead and turn off my strike through and pick B. That is the correct answer. So if you got this right without my help, go ahead and explain to me how you did it. Maybe you did it a different way than this. And if you did, that's fine. Maybe you went ahead and decided to use the quadratic formula. However you did it, go ahead and explain it. But if you did it like I did it, then explain the process that I just did here. Imagine you're trying to tell somebody how to do it who doesn't know how to use this calculator. Keep it short and simple and just explain the steps. Then pause this video, try the next problem on your own, and see if you can get it right. For problem number 7, notice it says, a store manager adjusts the price of an item each week that the item goes unsold. The price of the unsold item in dollars after X weeks I'm going to come over here. Since I see a variable, I'm going to highlight it. Can be modeled by the exponential function f of x is equal to 320 times 0.9 to the x power. Choose the correct answer from each drop-down menu to complete the sentences. The initial price. Okay, so it's going to ask us to answer some different things. So let me go and highlight that, make that stand out real quick. Of the item before the store manager made any adjustments was one of these values here. And then it says the price of the item either increases or decreases at a rate of, and this is the percent, right, that it's going to change each week. So now we know we're looking for 3 things. We want to know the initial price. We want to know if the price increases or decreases. And we want to know the rate. So I'm going to actually highlight the word rate. And remember, there's some work to be done to figure out the rate. So let me write down what I do know. So far, what I know is we have f of x is equal to a b to the power of x. I need you to remember, right, once again, A is my y-intercept. I'm going to write y-int, short for y-intercept. And B is going to be my growth or decay factor. To get the rate out of this, we're either going to have to add a 1 or subtract a 1. So let's go ahead and write the equation that they gave us. So they said that the equation was f of x is equal to 320, that's my a value, times my factor of 0.90 to the power of x. Now I want you to remember this. This b value right here, this is b, right? And so this is b right here. If it's decay, then b, I should write this in black, is going to be less than 1. If it's growth, then b has to be greater than 1. Now I want you to notice this b is less than 1. So since this b is less than 1, it's decay. So this is a decay situation. Decay just means that it's going to decrease the price. So I'm going to write decrease, and we'll go back and fill that in just a minute. So I know price is going to be decreasing. Now, when it comes to the y-intercept, not only does it represent the y-intercept, and I should have just wrote the whole word out, the y-intercept also represents the initial value. We talked about this in class, so we already know part of the answer right in the beginning. We know what the initial value is. It's a, and a is 320. So 320 is going to be my initial value. So I'm going to go ahead and put that in the box. Let's go over here. It says the initial price, our initial value, in other words, where we started from, was $320. The price of the item, well, because we know that it decreases, because this is a decay factor, because my b, my decay factor, is less than 1. It said because this number right here in place of b is less than 1, we know it has to be decreasing because it's decay. So I'm going to put decreases. Now we got to figure out the rate. This is the hardest part of it. It's going to be one of these numbers that they gave us. And I know a lot of you are probably tempted to pick that 90% because you see 0.9. But what you got to remember is how we got the decay factor. So here's how we got this. I'm going to write right here. The way we got this is b is simply equal to 1 minus the rate. Okay, so now coming back here, you'll see that I did some work. I had b is equal to 1 minus r. And if I want to figure out what number was subtracted from 1, in other words, my rate, I have to go ahead and take 1 and subtract 0.9 from it. Now, I can just tell right there, this one is kind of, since it's 0.9, I know in my head that it's 0.1. But we can always get our calculator and we can check it. So I'm going to get my calculator real quick just to make sure that I didn't mess up on the math. And I'm going to do 1 minus 0.90. So the reason I put 0.90 right was because that's what we had in our b value here. And I know that I got that number by taking 1 and subtracting the rate from it. It'll just leave me what's left over, which is the rate. Now, so the rate, notice, is 0.1. But if I multiply it by 100 to turn it to a percent, because that's how we convert a decimal to a percent, it turns into a 10. So therefore, right here, my answer, my rate that was subtracted to give me 0.9 for my decay factor was 0.1 or 10%. So now I'm going to go back over here and I'm going to look, and I notice that 10% is an option. So I'm going to click on it. This is my answer. I now put my initial price, which is $320. That was my y-intercept or starting point. I put that it decreases because my growth factor, or let me rephrase that, my decay factor was less than 1. And then I figured out that it was 10% as far as the decay rate, and that was because that's what I would need to go ahead and add to 0.9 to get it back to 1, right? Because we started out with a 1 and we had subtracted the rate. So here's what I want you to do. Explain to me if you got this right. Explain to me how you did it. Maybe you did it differently. But if you got it wrong, explain to me the process that you've seen me do to get it right, so you can get credit for it. And then pause this video and see if you can get number 8 correct before watching it any further. Now on number 8, Notice this says which expression is equivalent to the square root of 75. So there's a couple of different ways that we can do this, but the easiest way is how I showed you in class, which I call prime factorization. So we're going to actually use prime factorization to get the answer and go from there. So let's take a look at number 8. So if I got number 8, I'm going to start out by putting my radical, which is square root of 75. And then what I want to do is, remember, we want to break it apart. And I always tell you that my favorite number to use is 2, but if 2 don't work, then we try 3, and so on. But we just want to use prime numbers. And when I say prime numbers, we're going to use these numbers, for instance. Numbers that can only be divided by 1 are themselves. So a prime number is 2, 3, 5, 7, 11. Those are typically the numbers that I would use right there. And usually once you go to 11, somewhere between here, it's going to work out. Every once in a while you might have to go to 13. But I always like to start with 2. And if 2 doesn't work, well, then I go to 3. And if 3 doesn't work, I go to 5. So let's go ahead and try my favorite number, 2. So I'm going to bring up my calculator, 75 divided by 2. And notice it doesn't give me a clean number, so 2 won't work. I'm not going to worry about 2. I'm going to try the next one. I'm going to try number 3. So 75 divided by 3. And notice it gives me 25. So when I write this out, what I'm going to write is I'm going to write 3 and 25. And then we want to go ahead and we want to see if we can factor it again. Unless you recognize it's a perfect square. Now, I recognize this is a perfect square, but some of you may not have. And if you didn't, don't worry about it. We'll just try to do the division again. So if you're not sure about what numbers can divide into it, you can start with 2. If it doesn't work, then you can go ahead and go to 3. If that doesn't work, you can go ahead and go to the next number, which is 5. And if you look, 5 does work. And not only does it work, right, but we can tell now this was a perfect square. Because when we divided it by 5, we get that same value, 5. So I'm going to write that down, 5 and 5. And now we're done. Because the last number that's on the bottom right hand side, notice it is a prime number. And if it is a prime number, then you can stop. You don't have to go any further. So what I'm going to do now is I'm going to turn all of these into radicals. In other words, that's square root of 3. And this next one is going to be the square root of 5. And the last one is the square root of 5. And remember, we only take the values that are on the left, and that's over here on the right. So this is basically, we have 3 all by itself, so we're going to bring it down. That's my radicand, right? It doesn't change. And then, I'll say my radicand, that's going to be my surd, right? It's the part that we don't change. And then if you look at this one, right, we have a radicand of 5 times a radicand of 5. And remember, anytime you have a radicand times itself, it's just going to give you that number. That's just a rule. So square root of 5 times square root of 5 is just simply 5. And that is my answer. We used prime factorization to factor this out, and the answer is 5 square root of 3. So if we come over here, notice that is going to be answer A. It's the first answer they have on there. So maybe you did it a different way. If you did it a different way, go ahead and explain it if you got it correct. And if you didn't get it correct, I want you to go ahead and explain the way you saw me do it.